Welcome students. In this video we're going to talk about inflection points. So inflection points, I'm going to give you 3 graphs where there could be an inflection point. So let's say the graph starts like this and it goes like that. So a point of inflection, let's say, is a is a point. Let's say this is x, your x naught, let's call it x naught, or c, let's call it c. So c, f of c is an inflection point if the graph has a tangent line at that point. So here the tangent line has a positive, is going up, it has a positive, is increasing, going up. So this point here, this is called the inflection point, because here we're going concave up and then concave down. So this is one type. Another type is, for example, when the graph, so this is concave down and this is concave up, but here the tangent line, so c, f of c, so this is your c, the tangent line is horizontal. So first of all, the tangent line has to exist when there is an inflection point. It has to be horizontal, going up, and on the next example I'm going to show you, it's going to go vertically. So here the tangent line is horizontal. So here it switches from concave down to concave up. So the last type that I'm going to show you is when you have your graph and then there is a sudden switch here. So this is, the tangent line is vertical. So this is your c. So here's your c, f of c, and this is an inflection point because that here we're going concave up and here concave down. So that means that we're switching. Whenever we switch, that means that that's an inflection point, but the tangent line has to exist there. So it could be horizontal, vertical, or going up. Those are the 3 that I show you so far. So let's look at f of x that we have here. So f of x is equal to negative x cubed plus 6x squared minus 5. So the first step is to take the derivative. That will be negative 3x squared plus 12x. The second step is to take the derivative, the second derivative of f of x. So that will be negative 3 times 2, that will be negative 6x plus 12. So this here is first step. Second step is to set f double prime of x equals 0. That means that negative 6x plus 12 equals 0. So negative 6x equals negative 12 divided by negative 6 divided by negative 6. So x equals 2. So 2 is a possible inflection point. So the way we're gonna do it is we're gonna set the intervals. So for example, negative infinity less than 2, and then 2 negative infinity. So we can choose, let's choose, so the test point that we're gonna choose, so let x equals, in this interval, let x equals let's see, 1, and here let x equals 3. So when we plug in x, so f double prime of 1 is equal to negative 6 times 1, that's negative 6 plus 12, that's 6. So this is greater than 0. And then x of 3, that will be negative 6 times 3, that will be negative 18, plus 12, that's negative 6. So that's less than 0. That means that we were switching. So here we have concave up and concave down. That means that 2, because we're switching between concave up to concave down, that means that at x equals 2 we have an inflection point. Because we're switching between concave up to concave down. Thank you very much, students.